Okay, so substances change state when you heat them up, that's fine. But how come, even at the same temperature, different substances can be in different states of matter? Different substances might have different particles that are actually genuinely somehow different. You know, what if one substance has particles that just aren't very attracted to each other? And so a little bit of vibration at room temperature is enough to have them not attached. So that might be a gas or a liquid. Whereas another set of particles from a different substance, they might be very attracted to each other, and it might actually take a lot of energy to break those apart. So this substance would be a solid at room temperature. And how can it be that two different substances that are in the same state of matter can be different densities? Well, I think if we go back to the different particles for different substances idea, then this is easy to explain as well. You know, maybe some substances are really dense because their actual particles have a lot of mass, whereas other substances are not dense because their particles are actually quite light. And there's one more thing. Why is it if I get a gas and I try and squeeze it down into a smaller space, does it increase in pressure even at the same temperature? This one's tricky. Let's see how we go. In this box, I've got a bunch of particles, model particles, and we're going to pretend they're a gas, and they're going to be bouncing off the walls of this box. It's the bouncing off the walls that causes pressure on the box. So there we go. There's the balls bouncing around. They don't bounce off the walls very often in this case, so there's not a very high pressure. But if we put them in a little box, if we squeeze that gas down, they're going to bounce off the walls a whole lot more often, which means we've got a much higher pressure in the smaller box.